In this video, we're going to use the unit circle to estimate two solutions to each equation. The first equation is cosine of theta is equal to 0.3. Now, because we're working with a unit circle, we know that x is equal to cosine of theta. So solving cosine of theta equals 0.3 is the same as finding the values of theta where the x-coordinate is equal to 0.3. So we look along our x-axis and we locate 0.3 and we draw a vertical line. Next, we determine where that vertical line intersects the unit circle. One intersection point occurs between 1 and 1.5, and it looks like it's about 1.3. Continuing around the circle, the other point of intersection occurs at 5. So theta is approximately 1.3 or 5. These are the two solutions to our equation. Now, if we want to verify that these are actually correct or reasonable, we can use a scientific calculator. I'm going to go ahead and use Desmos. First, I check to make sure that Desmos is in radian mode. So I go to Settings and make sure that radians is highlighted. And now I can check our solutions. One of them was 1.3. So I find cosine of 1.3. And notice that that rounds to 0.3. And we also want to check cosine of 5. And that also rounds to 0.3. So 1.3 and 5 are reasonable estimates. Now, to get our angles more precisely, we could use inverse trig functions. In order to find our first angle, theta sub 1, we could find the arc cosine of 0.3. Just type in arc cosine of 0.3. And that comes out to be about 1.266. So to represent that on our unit circle, we would draw a ray through 1.3. Draw a counterclockwise rotation, and this would be theta 1. Now, in order to get theta 2, we'll draw a ray through our second point. And for that, we start on the positive x-axis and rotate all the way around. That's our theta 2. But in order to find it, we could see that we could do a full rotation, which would be 2 pi. So we're going all the way around the circle, and then we go back theta 1, which is the 1.266. So for theta 2, we take a full rotation, which is 2 pi, and we take away theta 1, which is 1.266. So 2 pi minus the arc cosine of 0.3. And that gives us 5.017. For part B, we want to solve the equation sine theta equals 0.7. And according to our definition, y is equal to sine of theta. So we want to figure out where is y equal to 0.7. So this time we locate 0.7 along the y-axis. We look horizontally across. And this time one of our solutions is about 0.8. And the other solution is right before 2.5 at 2.4. So theta sub 1 is approximately 0.8, and theta sub 2 is approximately 2.4. Now, if we wanted to do better than that, we could use inverse trig functions, in this case inverse sine. So theta sub 1 would be equal to the arc sine of 0.7. So just looking at our diagram, we draw our ray, and this would be theta sub 1. And then in order to get theta sub 2, we might notice that theta sub 2 is a little bit less than half of a revolution. So what we'll do is we'll go a half a revolution, which is pi, and then we'll go back theta sub 1. So theta sub 2 is equal to half of a revolution and then minus theta sub 1. Using Desmos, the arc sine of 0.7 is about 0.775, and that does round off to 0.8. And then pi minus the arc sine of 0.7, that comes out to be about 2.366, and that rounds off to 2.4. So we did really well on estimating from the given unit circle, but we can use technology to get even better estimates. I hope that helps you out.